All right, so let's go ahead and get started. Today we'll start on, we'll continue the discussion of local variables and parameters. And instead of just talking about local variables and pass by value parameters, now we'll get into pass by reference parameters, okay? But before we go any further, I have to show you why pass by value parameters are not enough to do everything that we need to do with algorithms. Because instead of just talking about, oh, this is a new mechanism, sometimes, or most of the time, I want to show you why we need the extra mechanism that we are going to talk about. So we'll start with a tracing the program, relatively simple one, but nonetheless, it will show us that, we don't have, the mechanism to do what we need to do. All right. So we'll say define sub, and this time, this is called swap. In other words, you give it two things, it will swap the values between those two things. Okay? And to do that, it's actually pretty easy. We have one pass by value parameter, I just call it x. Another pass by value parameter, we call it y. And we have a local variable t in this case. The algorithm itself is, okay, we'll make t the same as one of the inputs. We'll make x equal to y equal to t, and define sub, and that's it. So fix the indentation, and then we will have, we'll have another two global variables. I, has a value of say 5. J has a value of say, 9. And then we'll invoke the subroutine called swap. And then we'll say, I can be used to specify parameter x. J will be used to specify parameter y. And then we'll see what happens with this program when it executes. Oops. There we go. The objective is to swap or exchange the values of variables I and j. So we'll see what this program is going to do, and then we'll go, what can we do to make this program do what it is supposed to? All right, so let's go ahead and trace this program. And this is also a good review of the concepts that we have already talked about. We don't need comments because in this case we don't have any conditional statements. So we'll start with line number and the two global variables I and j. Because they are global variables, unless I say otherwise, they always start with some unknown values. That's our precondition. So on line 9, which is the first line outside of the definition of any subroutine, we initialize I to 5. On line 10, we initialize j to 9. And then on line 11, we invoke the subroutine. Now, in this case, invoking subroutine swap requires the allocation of a few columns, not just one. But we'll start with the one that always has to be there when we invoke any subroutine. It's the return line number column. There are no other lines to execute after the invoke, so the return line number is post, basically to remind ourselves that when the subroutine is done, so is the whole program. And then we need one column per parameter or local variables. In this case, we have two parameters, x, y are parameters, and t is a local variable. Each one requires its own column. Let's start with the easy one. T is a local variable. As a local variable, it always has an unknown value to begin with. That part we know already because we talked about local variables first. What about parameters passed by value? Do you guys remember how I compare passed by value parameters to local variables? They're almost the same thing, except for one thing. The initial values of passed by value parameters are determined by the invoke statement. The invoke statement is the statement on line 11 here. So what do you think would be the start value of x and the start value of y? Now, first thing is you don't want to say I here. That is not correct. Okay, it has to be a concrete value. When we are tracing, it has to be a concrete value. Okay, I has a value of 5, and j has a value of 9. y has an initial value of 9, because j has a value of 9 to begin with. Now this is the first thing that you should notice is, hey, as far as the subroutine is concerned, there are no linkages to I and j anymore, only to the values of I and j. All right, so let's go ahead and see what happens, at this point. We set up the columns. Now it's time to go into the subroutine, starting on the first line that has something to do, which in this case is line 5. Line 5 makes a copy of x in the local variable t. X has a value of 5, so now t has a value of 5. Line 6 is going to copy the value of y to x. Y has a value of 9, we'll copy that to x, so x now has a value of 9. Line 7 is going to copy the value of t to y. T has a value of 5, so now y has a value of 5. So as far as exchanging the values of x and y is concerned, the program got the job done, okay? Because initially x had 5 and y had 9. Now x has 9 and y has 5. Okay, so their values are exchanged. That's good. Okay, so we know the algorithm itself is actually correct. But then here comes line 8. Line 8 is the end of a subroutine. It has 2 jobs to do. The first job is to look up the rightmost return line number. In this case, it's post, so we know we have to continue execution at post after line 8. The second thing it has to do is to deallocate everything that was allocated for its invocation. So that means all of these columns are now deallocated. And what happened to the exchanged values? They're gone. What happened to I and j? Nothing. Absolutely nothing happened to I and j. Okay? So do you guys still remember I used the in-tray analogy for pass-by-value parameters? Kind of? Okay? Well, I forgot to mention one thing. When you put something into an in-tray, the in-tray is not really an in-tray per se. It's actually a copier. Okay? When you put something onto the in-tray, you are actually putting your original thing onto a copier. So the person inside the cubicle who's going to process the information is only using a copy of what you put onto the in-tray to process. At the end of the process, the copy is tossed into the waste basket. It's tossed into the recycle bin, basically. Okay? So this particular mechanism is not enough for us to actually exchange the values of global variables I and j. Are we doing okay so far in terms of those concepts? Why this program is not working the way it's supposed to. Okay. All right. If this is not working correctly, before we make any changes to it, let's go ahead and save it into a folder for today. cisp300. We'll save this program to today's folder. Okay. And I'll just call it into a swap by val. So the next program is going to be about the same. I'll call it the swap by reference, because we'll change the type of parameters to pass by reference. And the first thing we'll do is to change the program itself. The change to the program itself is kind of superficial. Okay, you guys will just go like, oh, so that's how we change the program. That's how we fix the problem. Everything in this case, that we said by val, we'll change it to by ref, which stands for by reference. The other thing we do is to change the arrows. So when we see a single-sided arrow, we change it to a double-sided. And we have to do the same thing with the other one. Just like that. And I claim that that will fix the problem. Well, you look at the pseudocode, the changes are very superficial. It doesn't quite explain how the problem can be solved. But when you execute a program, it makes a huge difference. So syntactically speaking, it doesn't make a whole lot of changes or differences, but when you look at the actual execution of the program, this part is all changed. So let's go ahead and make these a little bit larger because they will need more space. So the first part of the program has not changed. Line 9 and line 10 of the program has not changed. By the time we get to line 11, something has changed now. Local variable t is still a local variable, so it still has a question mark because it is unknown, has an unknown value. But x and y are now passed by reference. They're not passed by value anymore. Passing by reference means the parameter becomes a reference to the original object. So in this case, the way I denote it in a program like this is to say x is also known as column B, y is also known as column C. It's an alias. Okay? Note that I do not refer to I or j, I refer to the column that global variable I and global variable j lives in. Now, that is an important difference too. Okay? We do not refer to the name of the variables, we refer to the columns of those variables. Translating these into actual terms inside the computer, when you execute a program, when the program is in execution, especially with a compiled language like C and C++, the names will be all gone. What is only left is to refer to memory locations. So when I say column B is actually a memory location, column C is a memory location. Are we doing okay so far with this change? When a parameter is passed by reference, you cannot change that column anymore. So what's going to happen on, well, line 5 is easy. Okay, let's go to line 5 first. Line 5. Line 5 says here the right-hand side refers to x. X is also known as column B, and column B has a value of 5. So the right-hand side of line 5 is now evaluating to 5. So t, which is getting the value 5, is now changed to 5. That's the easy one. But when you look at line 6, it's a little bit more tricky now. Yeah?
Don't just tell me that post on the red line.
The post, sorry?
On your trace.
Return line.
You didn't say where.
Return line number? Oh yeah, sorry. Yep, return line number still has to be posted. So that part has not changed. Thank you. Okay, line 6 is now a little bit different. The right-hand side of line 6 is y. We look up y, it is also known as column C. Column C has a value of 9. So the right-hand side of the assignment operation evaluates to 9. That's easy. But what are we storing that 9 into? We are storing 9 to x. We look up x, it is also known as column B. We do not put the value here. We don't do it like this. Okay, this is not the way we do it. Instead, we say, oh, okay, x is also known as column B, so column B is the one that gets the value 9. That is the importance of passing by reference. It allows